A 75 milliliter solution of hydrogen chloride with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 molar calcium hydroxide. What was the concentration of hydrogen chloride in the original solution? So what is step 1? First, we need to draw a picture that illustrates all of the concepts involved in the picture. Then we can figure out how to solve the problem. Knowing how to draw a picture is really important because if you can convert the words of the problem into a conceptual diagram, you can solve any problem. So let's make a picture step by step. So it says that you have a 75 milliliter solution of hydrogen chloride with an unknown concentration. So we need to draw a cup with one chloride ion, which is negative, and one hydrogen ion, which is positive. Hydrogen chloride is a strong electrolyte, which coming apart into completely into ions. One hydrogen ion and one chloride ion for every molecule of hydrogen chloride in the container. Hydrogen chloride is an aqueous solution, and the volume is given as 75 milliliters. So there's the picture of the aqueous solution of hydrogen chloride. I can draw it, and so can you. Concentration is unknown, so molarity is also unknown. Calcium hydroxide will be added to the solution of hydrogen chloride. So we need to draw an aqueous solution of calcium hydroxide. So calcium hydroxide is also a strong electrolyte, so it will completely separate into ions. So we have one calcium ion and two hydroxide ions. The calcium is positive and the hydroxide is negative. And we have 27.3 milliliters of calcium hydroxide. I can draw it, and so can you. We will take the calcium hydroxide and pour it into the hydrogen chloride solution. When we do that, water and aqueous calcium chloride is formed. I can do it, and so can you, by converting the words into a diagram. This will make solving the problem a lot easier because we can look at the picture to know what is going on. The next step is to ask myself, what do I know about the given information? How can I take the given information in my diagram and start doing something with it in order to solve the problem? Look over here at the hydrogen chloride solution. The words of the problem say calcium hydroxide is added to the solution. I know what a concentration is, and in order to solve the concentration, I will need two things. I need the moles, but I'm asked for the concentration of hydrogen chloride. I need the moles of hydrogen chloride divided by the volume of hydrogen chloride. So we're going to multiply these two numbers to get the moles of calcium hydroxide. Okay, so let's recap. What I need to solve the problem is the moles of the hydrogen chloride. The volume was given 75 milliliters, so that is not a problem, which needs to be converted to liters, as well as the 27.3 milliliters converted to liters. What I have is moles of calcium hydroxide by multiplying these two numbers, and what I need is moles of hydrogen chloride to find the concentration of hydrogen chloride. How do I convert moles of calcium hydroxide into moles of hydrogen chloride? The answer is in the balanced chemical equation. The numbers 2 in front of hydrogen chloride and 1 in front of calcium hydroxide enable me to convert moles of calcium hydroxide into moles of hydrogen chloride. We will need to find the moles of calcium hydroxide by multiplying the concentration and the volume together to get the moles, right here. Now let's look at the details of the calculation. Since we need to find the moles of hydrogen chloride, since we need to find the moles of calcium hydroxide to find the moles of hydrogen chloride to find the concentration of hydrogen chloride, we need to multiply the volume of calcium hydroxide by its concentration to get the moles. First, you must convert 27.3 milliliters into liters by dividing it by 1,000 milliliters to get 0.0273 liters calcium hydroxide. Then you multiply molarity times liters to get moles. So you would multiply 0.157 molar calcium hydroxide by 0.0273 liters of calcium hydroxide to get 0.042861 moles of calcium hydroxide. In order to convert moles of calcium hydroxide to moles of hydrogen chloride, for every 1 mole of calcium hydroxide, for every 1 mole of calcium hydroxide, there's 2 moles of hydrogen chloride. So we need to multiply 0.004286 by 2 moles of hydrogen chloride over 1 mole of calcium hydroxide to get 0.0085722 moles of hydrogen chloride. We wanted the concentration, and now we are in that position to find it. The concentration of the hydrogen chloride is equal to the moles of the hydrogen chloride divided by the volume. 75 milliliters of hydrogen chloride must be converted to calcium by dividing 75 by 1,000 milliliters, which gives you 0.075 liters of hydrogen chloride. And so we have to divide the moles by the liters, which is 0.0085722 moles of hydrogen chloride by 0.075 liters of hydrogen chloride to give you 0.114296 molar of hydrogen chloride. And this is the final concentration, and this is the answer of what we were looking for. The moles of the hydrogen chloride divided by the volume gave the concentration. So good job, you got the right answer. Finally, let's look at the common mistakes. The biggest common mistake is to forget that the moles of hydrogen chloride can be found from the moles of calcium hydroxide through the stoichiometry in the balanced equation. If you write M1 V1 equals M2 V2, that equation is not going to give you the right answer. Never use that equation. You must convert the moles of one ingredient into the moles of the other ingredient by using the balanced chemical equation, and that is the biggest mistake that many students make.